All right, just to go through this really quickly again. Okay, so a function to determine a line will always have an x term and a y term, and these are going to be surrounded, okay, by the terms which help solve the function, as well, and I'm just going to put this in as a little extra here, as well as an equal sign. Okay, we also need an equal sign in between so that we can, that's going to actually be what creates an equation if there's an equal sign in there. Now remember, slope point, the slope point function, okay, of an equation is again as follows: y minus y1 is equal to m x minus x1, okay, and that's the form that we're going to be using, where x1 and y1 are some point on the graph and m is our slope. Okay, and when we plug that in there, then we're going to actually have an equation. And we're going to be taking a look at an example of that really quickly. Now, just a reminder that the signs in the function are opposite of the point. Okay, so because we have a negative or we're subtracting x1, when we actually come up with an equation, the sign that's here is going to be opposite of what the actual x1 is going to be, and same thing with y1, and we'll go through that in just a little bit. All right, let's describe the graph of a linear function. Okay, so example number 1. This linear function right here goes through these 2 points. Okay, and I'm going to label them out here. This is the point -1, -4, and this is the point 5, 5. Okay, so we have those 2 points that are along our line. The first thing we need to do is figure out what our slope is. So I'm going to draw out a little triangle here, rise and run, right there. Okay, rise 1, 2, 3, 4, 5, 6, 7, 8, 9. We have a rise of 9, a run of 1, 2, 3, 4, 5, 6. So our slope is rise over run, which is 9 over 6, which simplifies to 3 over 2. Now, if you want to do 1.5, that works as well, but it's a lot easier if we just leave it as an improper fraction. So we're going to have 3 over 2 being our slope. Now, once we have that, we then are going to use one of the points from our graph. And in fact, we could use either one of those. And I'll show you why in just a little bit here that it works, or somehow it will. Let's say we're going to use the point -1, -4. Okay, if we're going to use that point right there, then we're going to use this form, y minus y1. Well, this is x1 and this is y1. So we're going to do y minus -4, which is this. So if we do minus -4 is equal to our slope, 3 over 2, x minus x1, which is -1, and that becomes our equation. Now, if we're subtracting a negative, it's the same thing as adding. So what we can do is we can flip the sign. Y plus 4 is equal to 3 over 2, that should be a 2, sorry, x plus 1. And that would be our equation. And that would be the equation of our line. Now, the other way of doing it would be is if we were to use the point 5, 5. Okay, and so now this is x1 and this is y1. Okay, and again, whatever point we use is always going to be x1 and y1. And this will now be y minus 5 is equal to 3 over 2 x minus 5. Okay, and that there is our expression. Okay, now both of these are going to actually represent the exact same line. Okay, you know that they're parallel because they have the exact same slope, but they're also going to represent the exact same line as if we were to change them into graphic form or slope-intercept form, we would actually get the exact same form. Okay, I'm going to go through a little bit later on as to how we convert, but for right now, just trust me that these are exactly the same. If you really want to check with that, again, we're going to go through that a little bit later as to how they are in fact the same. Now, the second part here, let's graph a linear function that's described by this function. Okay, we're going to graph it based on this equation here. Let's change that to equation. Let's stroke that out. Let's change that to equation. All right, y minus 2 is equal to 1/3 x plus, or x plus 4. So we know this is x, or y minus y1 is equal to m x minus x1. Okay, our slope is 1/3. And our point that we're going to be using, okay, x1, y1, is -4, +2. Notice how it's the opposite signs because we're subtracting an x1. So the only way to subtract an x1 would be to get the opposite sign. So x1 is actually -4, and y1 is -2, or sorry, +2. Okay, so that's our point. So then what we're going to do is we're going to graph that out. So we're going to go -4, +2. So that's going to be our point right there, -4, +2. And then we're going to use our slope to find our next point. So starting from here, this is a rise over run. Okay, so we have a rise of 1 and a run of 3. Till we get this point right here, -1, +4. And then draw a line through. And I don't want to say it's as simple as that, but that is in fact, okay, so this is y minus 2 is equal to 1/3 x plus 4. Okay, but that is how we graph out something using slope point form. We take the point that we're given and we start there, and then we use a slope up 1/3 to find our second point and draw a line through. Okay, so remember that the slope does not represent two different points. The slope always is just how far apart the points are. It's a rise of 1, a run of 3. Okay, and that would be how we would graph out our function using slope point form.